Hi, grade 8s. Welcome to lesson number 2 of exponents. So, with exponents, we have a lot of laws. We have 5 laws, but it is a lot because you need to understand what is going on. So, yes, 5 laws look very easy, but do we understand what is going on? That is the problem. Right. So let's start with law number 1. Now, this is the law of exponents. The law number 1 is based on multiplication. So, meaning we will be multiplying some things right there. So, it's based on multiplication. So, this law only works when we're multiplying something, right? Yes. Now, let's look at the first example. So, the law states, the bases should be the same. Remember, this is a base, this is an exponent. This is also a base, and this is an exponent. So, the law states that we need to make sure that our bases are the same first. So, we have the base of A here, and we have the base of A here. That's the first part. We check if our bases are the same. Now, whenever we are multiplying bases that are the same, we are going to keep the base. We are keeping the base. We are not multiplying the bases. We are not dividing. We are not taking the base and putting it here and then it jumps the bridge and falls under the water. No. We check if the bases are the same when we are multiplying. And if the bases are the same, then the law also states that we are going to add the two exponents. So we have 2 and we are going to add it to 3. So we check the bases. If they are the same, we keep the base. So this is the base of A that we kept. Right, now let's simplify this. 2 plus 3 is equal to 5. And this is solved. Right. Now, the bases can be numbers and it can also be variables. Now, I'm going to explain what a variable is. But first, let me erase this. Right. So, what is a variable? A variable is an unknown, meaning we do not know what that thing is. So in mathematics, when we do not know what things are, we call them variables. For example, X, Y, Z, A, B, C, D, theta, beta, all of those things. So variables would be called unknowns. For example, the previous example was A. So we do not know what A is. Therefore, we call that a variable, but it's also a base in terms of exponents. So this is a variable. Right. Now we have numbers. We have 5 to the power of 2 multiplied by 5 to the power of 4, for example. Now, in this case, we still have bases, but now our bases are not variables anymore. Our bases are now numbers. So we have the base of 5, we have the base of 5. So we first check if our bases are the same and we are multiplying. So if we are multiplying bases that are the same, we keep the base. Then after keeping the base, we take our exponents and then we add them like that. So we have 5 to the power of 6. And you leave it in an exponential form. They're going to tell you that leave your answer in exponential form. So do you guys understand? When you're multiplying bases that are the same, then you can add the exponents. Now I want to test and see if you are listening. Right, so let's say we have a base of 4 to the power of 4 plus, I'm going to put 4 to the power of 3. Right, let's look at this. So we check if our bases are the same and we multiplying. Now, does that look like multiplication? No, it doesn't. This is addition. Therefore, we cannot apply this law. We are not going to say that the 4, we're going to keep the 4 and then we're going to add the exponents. No, this is wrong on so many levels. This law only applies to multiplication and nothing else. Do you guys understand? I hope you do. Right. So let's say we have another base. Now I'm giving you a base of 7 to the power of 2 multiplied by 7 to the power of 1. Pause the video, 5 seconds, do the sum, and let's see. 1, 2, 3, 4, 5. Right. Time is up. Right. So let's first check. We check if we have bases that are the same. So you see that our bases are exactly the same and we multiplying. Yes. Therefore, we can add our exponents. So we have 7 to the power of 2 plus 1, which is going to be 7 to the power of 3. Like that. And that's what it means. Right. Now I'm giving you another 5 seconds and I want you to attempt this. Let's take a variable. Let's make it m. M to the power of 4 multiplied by m to the power of 6. For example, 5 seconds. Do this one. Ding, 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 ding. 5 seconds is off. Yes. Right. So we check if our bases are the same and we multiply. Now, if our bases are the same, we are going to add our exponents. So we keep the base and we add the exponents. So when we add 6 and 4, we're going to get m to the power of 10. Like that. Right. On this side, I'm going to write another sum and I want you to tell me what the difference is. So we have 2m to the power of 4 multiplied by 3m to the power of 6. Right. So let's look at this and let's look at that. So looking at these two, we can see that now we have these numbers in front of the bases or the variables. Now, what does these numbers mean? When you have a number in front of a variable, for example, if you have x and here they put 2, this 2 is called a coefficient. Coefficient. So the 2 in front of the variable or the base is called a coefficient. Guys, see that? So here we have a coefficient of 2 and here we have a coefficient of 3. So this number in front of the unknown, in this case the unknown is m, is called a coefficient. Guys, I'm so sorry, you'll have to pause the videos if you want to understand what is going on, because now I'm erasing very fast. Right, so how do we do this one? Now that we have coefficients, it's a problem. But then it's easy. We actually take our coefficients and we multiply them. So we have 2, we multiply it with 3. So we first take our coefficients. Then we go back to the rule that says when you have bases that are the same and you are multiplying, it means that you're going to take your exponents and you're going to add them. So now you have m to the power of 4 plus 6. Right. So let's solve this. We have 6m to the power of 10. And this is our answer. So the difference between this and that is because we only have coefficients here, but here we do not have any coefficients. But actually we do. Remember, if you don't have a number in front of a variable, it simply means it's 1. Yes, it's 1. And 1 times 1 is actually 1. Hence, we do not write it. So you do have coefficients there. It's just that the coefficient is 1. Yes. So 1 is a placeholder. It doesn't change anything, honestly. That's why sometimes we do not write it.